In a traditional IT setup, networks are built with physical hardware. You use physical cables to connect machines, routers to direct global traffic, and switches to handle local packet delivery. Buying and maintaining these physical routers and miles of cable requires significant upfront capital. It also restricts your ability to scale quickly, locking you into the physical capacity of a specific data center. The AWS cloud replaces physical iron with software-defined logic. You configure your network topology programmatically without touching a single cable. At its core is the Amazon Virtual Private Cloud, or VPC. This acts as your isolated private boundary within the larger AWS environment. If preparing for the AWS Certified Cloud Practitioner exam, understanding how to configure the isolation, routing, and access controls of a VPC is required knowledge. Network security in the cloud relies entirely on how you architect these programmable rules. AWS clusters data centers into geographic locations called AWS regions. An Amazon VPC is a regional resource. It cannot span multiple regions. Within that region, AWS builds availability zones, isolated, physically distinct data center clusters located miles apart. AWS separates these zones physically to ensure that a localized disaster, like a flood or a massive power grid failure, hitting one availability zone leaves the others operating normally. To deploy resources like servers and databases, you partition your VPC's IP address range into smaller virtual networks called subnets. This brings us to the second critical rule. Unlike the VPC, subnets are strictly confined to a single availability zone. By placing AZ-scoped subnets within a regional VPC, cloud architects natively design systems that automatically survive localized data center failures. Traffic leaving subnets is directed by route tables, rulebooks dictating where packets travel. To connect outside, attach an NAT Gateway, IGW, to the VPC boundary. A subnet becomes public only when its route table points traffic directly to that IGW. Without that specific route, a subnet remains private. It is completely inaccessible from the public internet. This creates an architectural problem. Your private backend database servers still need to reach out to the internet to download operating system patches and software updates, but they cannot be exposed to external attackers. To solve this, place an AWS-managed NAT Gateway inside your public subnet. Private instances route outbound requests to the NAT, which translates the private IP and forwards traffic out. Crucially, the NAT automatically blocks direct inbound connections from external hackers. Explicitly defined routes and gateways form the traffic control system, effectively separating publicly accessible web servers from securely isolated data. Routing traffic is only half the battle. To secure both the subnet perimeter and the individual servers, you need granular firewall rules. Your first line of defense is the Network Access Control List, or NACL, which wraps around the entire boundary of a subnet. The defining characteristic of a NACL is that it operates as a stateless firewall. Because it is stateless, the firewall has no memory of active connections. Return traffic trying to leave must be explicitly authorized by an outbound rule. NACLs process rules in strict numerical order. They are also unique in supporting both allow rules and explicit deny rules based on specific IP addresses. Moving inward, your second firewall layer is the security group, which wraps tightly around individual EC2 instances or network interfaces. The defining characteristic of a security group is that it operates as a stateful firewall. It remembers active connections. If inbound traffic is allowed past the gate, the return outbound traffic is automatically allowed to leave. Unlike NACLs, security groups only process allow rules, defaulting to implicitly denying everything else. True defense in depth requires combining the broad, stateless denial capabilities of NACLs at the subnet border with the specific stateful application logic of security groups at the instance level. Most large organizations operate in a hybrid model, requiring secure communication bridges between their private cloud VPC and their physical corporate offices. The standard method for this is AWS Site-to-Site VPN, which establishes an encrypted tunnel over the public internet to link your data center directly to AWS. To configure this, you deploy a customer gateway on premises and connect it to a virtual private gateway on your VPC. For enterprises needing a premium alternative, AWS Direct Connect completely bypasses the public internet. Direct Connect provides maximum security, ultra-low latency, and consistent throughput. However, requiring physical fiber provisioning means it can take months to establish. For individual remote developers, AWS Client VPN allows them to connect securely to the VPC using an open VPN tunnel straight from their personal laptops. To access other native AWS services while keeping traffic strictly within the internal network, architects use VPC endpoints and AWS Private Link. Whether through encrypted public internet tunnels or dedicated fiber lines, AWS provides multiple scalable on-ramps to securely bridge legacy on-premises infrastructure with the cloud. Building a secure VPC follows a strict hierarchy, starting from a global geographic region down to multiple availability zones. Inside those zones, AZ-scoped subnets provide the foundation for fault-tolerant applications. Route tables govern exactly how those subnets communicate with the outside world, utilizing internet gateways for public web servers and NAT gateways for secure backend updates. Every packet crossing those boundaries is inspected twice, first by the Stateless NACL guarding the subnet border, and again by the Stateful security group protecting the instance. Mastering this software-defined networking stack equips you to pass the Certified Cloud Practitioner exam and provides the blueprint to secure any application you build in the AWS cloud.